Thank you for joining the Fire Suppression Systems Association's webinar on water mist, special hazard applications, technologies, and design principles. Your phone lines have been muted. If you have any questions during the presentation, please type them in the question box on the bottom right-hand side of your webinar control box, and we will take them at the end of the presentation. This webinar is being recorded and will be available to download after the presentation is over. With us today, we have our webinar chair, Todd Stevens with Cantor Straro, and our two presenters, Jason Jones with Fike Corporation and Jonathan Ingram with Kidde Fire Systems. I'll now turn the mic over to Todd to introduce our presenters.
Thank you, Becca, and welcome everybody to today's FSSA webinar. Just a few quick announcements before we begin. First thing, I'm thrilled to announce a save the date for next year's FSSA annual forum to be held in February of 2020 in Kissimmee, Florida. Additional information will be available real soon, so please keep an eye out for that. I'm also excited to thank our sponsor for today's webinar, Victaulic. Victaulic is the world's leading producer of mechanical pipe joining solutions. In the fire protection market, they design, engineer, and manufacture a wide range of products. Their hybrid fire extinguishing system, Vortex, combines the benefits of water mist and clean agent technologies. This year marks Victaulic's 100th year of innovation, dating back to their original pattern. Victaulic is proud to sponsor the webinar for FSSA. So today's topic is water mist, special hazard applications, technologies, and design principles. We have two extremely knowledgeable presenters for the topic today. We first have Jonathan Ingram, Kidde Fire Systems. Jonathan has 20 plus years experience and has held a variety of various application engineering, product specialist, product management, and sales management positions with Kidde Fire Systems. And in 2017, he was appointed as the Director of Sales for Marioff North America. He published white papers on a variety of special hazard topics, and he serves as a principal member on NFPA 76, NFPA 855, and as an alternative member for a number of other NFPA standards. Our second presenter is Jason Jones, a global product manager, fire suppression products at Fike Corporation. Jason manages Fike's global portfolio of water mist and gaseous agent suppression special hazard fire protection products. Jason joined Fike after a career in the energy industry that included product management, operations, and business development. I have the pleasure of knowing both of these presenters personally, and I'm thrilled to have them with us today. With that said, I'll hand it over to Jonathan.
Thanks, Todd. Okay, so first what we figured we'd do is we'd talk about what is water mist. There's a lot of confusion in the marketplace of what is water mist and those type of things. However, NFPA 750 pretty much defines what qualifies as a water mist type system. And, the first paragraph that you see on your screen really is the definition that you will find in NFPA 750 section 3.3.2 or 3.3.22. However, to put it in layman's terms, what this really means is that 99% of the water droplets that are discharged from the water mist head actually has to be under 1,000 microns to be considered a water mist system. Next slide. So there's several different applicable standards that you can use that govern water mist type systems. FM approvals, which is heavily involved in approving these type of systems, providing their listings and everything else, doing fire tests, list these particular type of systems under FM 5560. As mentioned before, NFPA 750 is the standard on water mist fire protection systems, and UL does have a slight entry into the water mist realm where they list a water mist nozzle or spray head or sprinkler head under UL 2167 for ordinary hazard 1 type occupancies. So just to kind of summarize a little bit of where you might see or where you can use these standards, NFPA 750 and both 5560 are considered design and installation guidelines, while also 5560 and UL 2167 would be considered fire test protocols. Also, 5560 and 2167 would be considered component test protocols and also approval protocols. There are other protocols around the world, such as SEN, VDS, VNEPO, GOST, and various others that are used in the international market. However, today we will be addressing mainly the North American guidelines or domestic US/Canada or other UL, FM approval recognizing countries. Next slide. So in addition to these, to the standards, there are other applicable standards which water mist design and servicing are taken from to help kind of define how we define hazard classifications, how do we do some system dimensioning guidelines from a preliminary baseline. When looking at sprinkler heads that are used in water mist type systems, just like in NFPA 13, they do have some designations when using fusible bulbs in the sprinkler heads that you have to meet either standard, intermediate, or high temp hazard classifications. So, and those are really defined by the temperatures that could be or that the bulbs could be exposed to on a regular basis. Also, on NFPA 25 does have some parts in there that talks about inspection, testing, and maintenance, but it deals with things like periodic sampling and inspection of heads, system testing and inspection documentation, different types of things, but it's mainly to deal with water-based systems. So there are some things within NFPA 25 that the water mist systems have to follow under the inspection, testing, and maintenance guidelines. Next slide. So when looking at a water mist type of system, what kind of criteria should you really be looking at? First of all, you really need to define or see what third-party approvals does the system have. Does it have FM? Does it have an aspect of UL for OH1? Does it have another agency approval that can be used or recognized in the jurisdiction that you are trying to install a system or design a system in? Also, if there aren't any third-party approvals, because maybe FM or UL have not developed a particular test protocol for a certain type of area, and those type of things, the next thing you really want to do is what fire testing has the manufacturer done to support the design of their system. There are a number of tests that manufacturers do independently to verify that the system will work, is suitable for that particular type of application, so on and so forth. And on top of that, once they do the fire test, they may be able to publish or will publish fire test summaries or some sort of supporting documentation that they should be able to share with the design engineer, the authority having jurisdiction, the end user, and others to justify why they are taking this particular design approach for this particular system. Next slide. So when looking at third-party approvals, we really need to look at what type of approvals do they carry. In the case of FM, which I know Jason later on down in the presentation will be talking about the different hazard classifications and what they actually entail. However, FM does qualify hazard class 1 or HC1, or also referred to as light hazard, machinery space, data centers, oil cookers, and those are just a few of the FM approvals that you would see for a water mist type of system. For Underwriters Laboratory, as I mentioned before, there are ordinary hazard listings for a water mist type of system, mainly for ordinary hazard 1 or OH1. And I did put a couple examples in here from the definition from NFPA 13 that is widely used to define this particular type of hazard. And these are some of the different types of applications that you would actually see as part of OH1. The hazard classification, of course, would always be classified either by the engineer, the design engineer, or the authority having jurisdiction for the area that's looking to be protected. So these OH1 type areas could be automobile parking and showrooms, industrial bakeries, canneries, tape storage rooms, electronic plants, just to name a few. Next slide. So when we talked about fire tests and fire test summaries, this is just an example of what a manufacturer might be able to supply when a standard may not be available for a particular application that you're looking to protect. In the fire test summary that you see on your screen here, this is just an example of some testing that was done for road tunnels and the protection of them. That does not necessarily have a FM, a UL, or other standard that kind of guides them through or guides someone through a third-party approval. However, this here will summarize, or the fire test summary will summarize a full-scale performance-based test, also identify the fire test scoping, the parameters, the results, what dimensioning criteria was a result of the testing so that it can be applied to the application or the hazard. The manufacturer should be able to supply this or some sort of backup data for the design approach and make that readily available to the engineer or to the authority having jurisdiction. And again, we are using these mostly when third-party approvals are not officially available because they may not have a test protocol previously set up in their approval guidelines for a particular application. Next slide. So there are different types of water mist systems that are out there, and these are all classified by NFPA 750. So you have low pressure water mist systems, which typically are under 175 psi in working pressure. Intermediate pressure is 175 to 500 psi in working pressure. And then high pressure is anything over 500 psi. Next slide. So there are different types of pump units that you can find with water mist type systems. Some of them in this particular case, we're showing a gas-driven type of water mist system that comes in all different shapes and forms. To the two pictures to your right on the display show ones that are nitrogen-driven, where you have a water storage tank or tanks, which the nitrogen then pressurizes, pushing the water out of that tank into the protected space through the spray heads or nozzles. The one to the left of the animated picture there, that is what they call a gas-driven, another type of gas-driven pump, which really the nitrogen is used to basically pressurize the pump piston, and by driving that pump piston is what actually creates the pressure in the system to deliver the water and create the pressure at the nozzles that then break the molecules up into the small particulate called water mist. Now, one thing to note in gas-driven systems that is different and defined in NFPA 750 is that any gas-driven system that typically gains their pressure from a nitrogen driver or compressed air array will not basically have the nitrogen or the compressed air contributing to the extinguishing effects of the room. So basically, the nitrogen that's used is strictly, or the compressed air that's used is strictly there to drive the pump. It's not there to reduce oxygen levels in the room or be a key or major extinguishing principle in extinguishing a fire in a particular hazard. Next slide. Then you also have electric-driven pumps. Electric-driven pumps come in all shapes and sizes, both low pressure and high pressure. The advantage of electric pumps is as long as you have electricity and a source of water, you'll be able to run these pumps, infinitely. You can stop and start them as you need them to be available. Once you stop them after an event, they'll be ready for the next event, right after you stop the pump the first time. So if you have multiple fires in a industrial type application where you're deploying water mist, for example, like an oil cooker or something to that effect, these type of pumps would be easily resettable and ready for the next event, should a fire happen on another piece of machinery or the same piece of machinery that had the fire in the first place. The electric pumps give you a lot of flexibility because of their capabilities of capacity of flow, but also because of being able to flow potentially long distances from a pump location to the protected space. Next slide. So when you're dealing with water mist is not necessarily a prescriptive type of approach like we see with clean agents or those type of things. But the effectiveness of the water mist system is directly related to spray characteristics of the spray head design or the head design that is used on that water mist system. And some of those characteristics that have to be taken into account is flow rate per unit area, distribution of the flow of the water, direction of the application, droplet size and distribution, entrained air velocity and droplet velocity. Now, because you're breaking up a large molecule of water into smaller molecules, it is very important that you have droplet velocity and entrained air velocity and distribution of those droplets, precisely and also uniformly, because that is going to definitely give you the effectiveness of the system when fighting a fire. Sometimes when you're dealing with higher ceilings and other types of areas where the fire might be further away from the spray head or the sprinkler head itself, the velocity that you project that droplet out of the spray head is really going to determine how effective it is in penetrating the fire source and the core of the fire at the floor level. Next slide. So when looking at low pressure, intermediate pressure, and high pressure water mist systems, you're typically, if you're taking a drop of water, a low pressure system is typically going to break those droplets into anywhere from droplet sizes of greater than 300 microns, but less than 1,000 microns in size. When you're dealing with intermediate pressure, it's going to break the droplets into 300 micron in size, droplets. And then with high pressure, they're typically breaking it into 50 microns in size. When you're breaking them into smaller microns and smaller number of droplets per, per droplet of water, what the benefit is that with each individual pressure of different water mist systems, you're able to cover and expand your surface area coverage with those droplets. So, for example, high pressure, you're increasing your surface area of that droplet, effectiveness basically 400 times. And then, from a vaporization standpoint, the smaller the droplet the smaller the droplet or the different size of droplets that you have are actually going to determine how readily those droplets are going to vaporize into basically steam, which creates a local inerted atmosphere at the fire core. So the faster the droplet evaporates into steam is going to determine as how quickly it starts its firefighting principles. Next slide. So this particular, when we talk about traditional sprinklers, because they've been used since 1887, people have a lot of familiarity with sprinklers and those type of things. They tend to be prescriptive in nature when you look at FM approvals or NFPA 13 or anything else. They're basically designed to achieve a certain water density based upon a certain hazard type. Typically, they'll tell you need a density of like 0.3 GPM, or different, or 0.3, and that will be prescriptive for various different types of applications or hazard types. Next slide. When you're dealing with water mist systems, they are performance-based. So we can't necessarily apply them in a prescriptive manner just because something might be similar. They have to specifically be performance-based tested, and in that performance-based testing, we have to be able to define nozzle type, operating pressure, spacing, water flow rate, max installation height, and max protected volume for that system. And just because one system has a particular listing, it doesn't mean or one system can pass a particular performance-based test does not mean that every other water mist system can do the same thing. So each manufacturer of water-based systems has to go through their own performance-based testing with FM or through their own fire testing to verify that this system will work on a particular application. Now with FM and UL, they have specific requirements to achieve data center approvals and the various different approvals that they give. So once you gain those approvals, that is passing that performance-based criteria for those type of applications. Next slide. So as I was saying, water mist, just because it's not a generic one-size-fits-all, water mist A, if they pass a test, doesn't necessarily mean water mist B systems will pass the same test. Next slide. So this is just an example of a performance-based fire that we would have to extinguish as part of FM approvals or any fire tests. This is an example of a pool fire test that was done in the test lab. And one thing to note, this is actually real time, so this is not, basically took about 30 seconds for that fire to be put out. Next slide. So this is another application for local application spray fires. So sometimes you'll have hydraulic hoses in industrial areas or on machinery that may break, gas turbines, those type of things that may break and then ignite into a spray fire. So we have to also, with water mist type systems, we have to be able to protect those type of environments. But again, as a performance-based test, in order to get the listing, you have to show that you can actually extinguish it. Now, one thing to note on that video, the fuel was actually still being discharged from the spray head as the water mist system was extinguishing the fire and put it out. Next slide. So how does a water mist system work? All right, so first you have a fire. Then as the fire burns, it's going to start pulling air into the fire to feed it as its fuel. As the air gets into the fuel, it provides that, or as the air gets into the fire, it's providing that fuel stock and everything else for the fire to grow. And then when you discharge your water mist system, what's happening is the small molecules of water, of the mist, are actually being entrained into the airflow or the the air intake of the fire, therefore penetrating the core. And as those molecules get into the fire, they expand about 1,700 times, therefore creating steam at the fire core, and then putting the fire out by basically choking off the fuel and the oxygen source at the core of the fire only. It will not reduce the oxygen levels within the space itself on a homogeneous basis. Next slide. So just to kind of put it, as everybody's familiar with the fire triangle, you have energy, fuel, and oxygen. Energy gets transferred to the fuel. It also gets transferred to oxygen. The oxygen and fuel feed into the fire. So by water evaporation of the water mist type of system, you're providing a cooling source to reduce the amount of heat that's actually being created by that fire. Also, when the water vapor is being pulled into the core of the fire, you're creating that local inerting type of environment at the core of the fire, therefore cutting off the fuel and oxygen sources. You're also doing some wetting of surrounding area, just as with a traditional sprinkler system, just not as much. And basically, this wetting will prevent other fuels from becoming involved in the fire itself. And then finally, with water mist systems, you're creating a radiant heat blanket almost. To kind of think of it like a foggy day, right? The sun's always out above the clouds, but as the fog burns off, you can start feeling more heat of the sun. Well, what the radiant heat absorption of a water mist system does is it absorbs the heat that's being given off from the fire and doesn't allow it to necessarily roll off the ceiling and activate multiple sprinkler heads that don't need to be activated, because you can control the particular fire with the water mist system using one, maybe two heads to control for that area, instead of having to discharge maybe 8 to 12 heads on maybe a traditional sprinkler type system to do the same thing. Next slide. So one thing that I want to make sure we don't get confused about, because there seems to be some confusion in the marketplace about hybrids versus water mist. So they are two different systems. A water mist is not a hybrid, and a hybrid is not a water mist. So NFPA 750 really governs water mist systems, where NFPA 770, which is currently in draft development, will govern hybrid type of systems. So some of the key differences between hybrids and water mist, and we get these questions all the time. Water mist can be used as a primary fire protection system. It could be used in place of fire sprinklers in various different types of applications, where and also from a water mist perspective, it doesn't reduce oxygen levels throughout the whole entire enclosure. It only does local inerting at the fire source, and it can be designed to meet sprinkler discharge requirements, whether it's 30 minutes, 60 minutes, or 90 minutes. In a hybrid type of system, the primary extinguishment is through N2 inerting or nitrogen inerting, which is lowering the oxygen levels down below between 12 to 16%. But it's also a supplemental fire suppression system. And what we mean by that is, when I talk about primary fire protection system, and I said the sprinkler system we can take a water mist system and replace a sprinkler system in that same space, for example, in a data center or an industrial complex, protecting certain machinery and those type of things. That can be the only system that has to be installed, where, from a hybrid perspective, if you're going into a data center or something to that effect, you would have to install a secondary type system, or I should say, this would be a supplemental system that would have to have a sprinkler backup installed in its for mainly life safety purposes. So those are some of the differences between hybrids and water mist. I do see, and we all see, a confusion in the marketplace between the two. So we wanted to make sure we pointed out the differences between what a water mist system is and what a hybrid system is. And with that, I'll turn this over to Jason, and Jason will go through the second half of the presentation.
Thanks, Jonathan. My purpose here is to kind of outline some of the primary advantages of water mist. Jonathan alluded to some of them, and then to go into a little bit more depth on the very specific approval protocols that FM has developed for fire or for water mist systems. So the number one by far advantage of water mist, especially when we're comparing it to sprinklers, is reduced collateral damage. Both systems obviously have their place and their role. When we want to protect the actual contents of a space, we're going to go with a water mist system because it's going to do a lot less damage to the contents of the space. When we compare a water mist system, especially in a light hazard situation where we're using a water mist nozzle that's got a glass bulb in it that's going to break under the heat of the fire and release the water, we're going to see about 50% of the water output that we would experience with a traditional sprinkler. When we're talking about a machinery space or a turbine enclosure where we're using a deluge system that's got an open head nozzle, where we're going to flow water through the entire nozzle network simultaneously, we're going to see as little as 1/10 the water output of a sprinkler system. And then when we talk about collateral damage, we can also speak in terms of microbiologically influenced corrosion. So when we have a water mist system, we're typically using potable water. That is, most water mist systems require that you use water that's drinkable. And then that water is going to be flowing through a stainless steel pipe in all likelihood. Sometimes we use copper, and then where we can regulate the pressure down to below 175 psi in a wet pipe system, we can even use CPVC pipe on a water mist system. When we're talking about a sprinkler system, we're typically using black pipe, and black pipe's got a little rougher surface than some of the other pipes, and it can lead to a buildup of bacteria, kind of think in terms of a bacterial sludge that over time can corrode the pipe and cause pinhole leaks or cause a whole section of pipe to fail and have to be replaced. And you can imagine what that water might be like when it comes out. Now, granted, on a sprinkler system, maybe we're not as concerned because we're not necessarily trying to protect the contents of that space. We're just trying to preserve the structure long enough for people to get out of it. Next slide. Water obviously is an environmentally sustainable solution. We take water out of the environment, we use it to put out a fire, and it returns to the environment. Now, we might have to be concerned about containing runoff depending on what we're protecting, just like we might with the sprinkler system. So if our water's going to get contaminated by hydrocarbon fuel or oil or some other contaminant, we might have to contain it. But it's not contributing to global warming. It's not contributing to ozone depletion. It's a green agent. It's the original green agent, if you will. Water mist is fast acting. So when we're talking about a machinery space or a turbine enclosure, we are using our water mist system in conjunction with the same kind of detection and control systems that we use on gaseous agent systems. So we're potentially detecting the very first molecules of combustion and discharging our system. So the system's going to go off hopefully before the fire can do any significant damage. And that's in contrast to a sprinkler system in a light hazard application where we might be waiting for a bolt to break and a nozzle to open that way. Another big difference between water mist, Another big difference between water mist and sprinklers is that water mist systems are three-dimensional versus a sprinkler that's purely two-dimensional. So a water mist system is three-dimensional in very much the same way that a gaseous agent system is three-dimensional. Jonathan mentioned the way that these sub 1,000 micron droplets entrain themselves in the convection currents in the space that we're protecting during a fire. And those convection currents draw the water mist to the fire and let it do its job. So if we've got a fire in a concealed space, maybe underneath a horizontal surface like a desk or a table, the water mist is actually going to penetrate those concealed spaces and do its job. Next slide. And another advantage of water mist is that it is just the ideal agent for certain types of fires. It's the best performing agent for certain types of fires. And these are typically Class B liquid flammable fires, especially spray fires where we might have a continuous fuel source. And you can think in terms of a ruptured hydraulic line or a ruptured fuel line, say on a diesel generator, where we're going to have a very hot spray fire with a high rate of heat output. The hotter the fire, the more quickly the water vaporizes, the more quickly it absorbs the heat of the fire, inerts the space right around the flame front, and puts out the fire. I'll show you a video here in a second that shows a shielded spray fire. So Jonathan showed you a spray fire. This is a shielded heptane spray fire that looks a lot like some of the fires that we have to demonstrate for FM when we get a system approved. And this is a fire underneath a steel table. And I think if a sprinkler system were to discharge in this space, I think it would work. I think it would run until the fuel source ran out. And what you're going to see here, you can go ahead and play the video. You're going to see the water mist exhibit that three-dimensional effect and go underneath this table. And we've edited this down. I think this fire took about 45 seconds to go out. I've got it down to 30. But you're going to see pretty quickly how it knocks that spray fire down. It gets a little further from the fuel source. You can tell that the space is being inerted, and the fire goes out very quickly in a way that I think a sprinkler would never be able to do. So another advantage of water mist. Next slide. Water mist also reduces the likelihood that we're going to have to upgrade a building's water supply. And that's because we're using 50% to 90% less water than we would with a traditional sprinkler system. So we can have a smaller water supply to our building. And we've experienced this in the real world. Just as an example, we've had fast food restaurants periodically say every 10 years will do a gut and rehab of their facilities to modernize them. Well, we've had instances where a restaurant's undergoing that process, and the local authority and the building owner look at the current water supply, they look at what's gone on in the neighborhood in the intervening 10 years, and they see that the infrastructure, the buildings around that restaurant have built up over time to the point that the feeder line from the main to that building is no longer adequate for that building's sprinkler system. So they're faced with trenching across parking lots and sidewalks and laying a larger diameter supply line. And when all of that's considered, at least in this case, that made water mist a very easy choice because they didn't have to go through that upgrade process. So even though the upfront equipment cost was a little more than the sprinkler system, when you factored in the total upfront cost, it was less. Next slide. Another advantage of water mist when we talk about infrastructure, and Jonathan alluded to this, is that we have the option to, when we've got a remote location where we may have a inadequate water supply, we may even have an electric supply that's not suitable without upgrade for a sprinkler pump or a water mist pump, we have the ability to use a containerized water mist system that's got a smaller than normal reservoir. So you see two examples of that in the middle and on the right. So I just off the top of my head can think of a law facility like a sheriff's department in a remote location on the East Coast where they did not have adequate water supply for a sprinkler system. So they go with one of these package units, and because the motor, the driver of the water, is nitrogen, all they have to have is 24 volts DC to open a solenoid and allow nitrogen to flow through the system and either turn an air motor or push water through the system. So we also see these package systems used a lot on island locations and coastal locations where you're cut off from the mainland and you've got a diesel generator that needs to be protected, and you need a system that can stand alone. Next slide. So I'll touch on with a little more detail on some of the FM approvals that Jonathan talked about. And if you read FM 5560, you'll see that they've got 9 very specific fire test protocols that they've designed testing requirements for, and that the various equipment manufacturers have gotten approvals for. And I'll try and kind of group them together for the sake of time. So we've got turbine enclosures and machinery spaces that look very similar. A turbine enclosure is a very specialized type of machinery space. What these spaces have in common is that we've got hydrocarbon fuel flowing through a system doing a job. So it could be a diesel generator, it could be a gearbox that's got lube oil supplied to it, it could be a bearing and shaft situation that's being lubricated, it could be the lubricating skid that's next to or underneath one of these other hazards. And so these types of hazards are subject to spray fires, pool fires, and that kind of thing. And when we're protecting this kind of space, we use a deluge system. So we're going to have open head nozzles, we're going to have electronic detection, typically a stick heat detector in a turbine, could also be linear heat cable or some other form of detection. And then you see off on the right some FM data sheets listed for each of these hazards. If you want to get into detail about the protection scheme that FM recommends for each of these hazard types, go to those data sheets and read them. They'll give you diagrams that talk about nozzle placement, and they will tell you which parts of the hazard need to have nozzles present to protect them, and really just a great source of information about how to protect the space. Another huge water mist application is obviously light hazard. And in a light hazard situation, we're going to use an automatic nozzle that works on the same principle as a sprinkler head, only it's going to produce a much smaller droplet. And when we're protecting light hazard, that can be done in either a wet pipe or a dry pipe or pre-action fashion. So we can either have water present in the pipe all the way up to the nozzles during non-fire conditions, or we can hold that water back with a valve and have that pipe network be dry during non-fire conditions. And we'll get a little deeper into that here in a second. Next slide. I want to talk a little bit about light hazard versus hazard category 1. So go ahead and click. If you look at NFPA's definition of light hazard, you're going to see these types of hazards specifically listed as defining light hazard. Next, click. And then if you look at FM, datasheet 3-26, where they define hazard category 1, you're going to see these very specific words used to define that hazard. Next, click. And if you look at both of these, NFPA 13 and FM, you're going to see that they use this list of words in the middle where the circles intersect. They both use those words. So the question would be, and we get this question a lot, can I only protect what I see listed where these circles intersect if I want to be compliant with NFPA and if I want to have an FM approved system? And of course, the answer is no. In both cases, these lists are meant to be representative. They're not meant to be definitive and all-inclusive. They are meant to give you examples of the types of spaces that fit within the FM definition and that fit within the NFPA definition. NFPA 13 specifically leads into their definition of light hazard with the words include spaces with uses and conditions similar to. So that tells you that This is a representative list. So I don't see music stores or pet grooming stores listed here. Can I protect those spaces? The answer is yes, I can. I see a lot of other types of hazards here that contain the same kind of combustibles that I would expect to find in these types of spaces. So next slide. Water mist is also used in a local application format, and FM's got a specific testing protocol for local app. CO2 is also used in local app. Those are really the two agents that we can use to protect a critical asset that sits within a larger space. So rather than protecting the entire room, we're protecting a hazard within the room. So when we do that, we arrange a grid of nozzles on all open sides of the hazard, and we're going to direct our flow of water mist through all nozzles simultaneously, so it's a deluge system, and we're going to hit that hazard from all sides with water mist. And FM's got a whole series of data sheets, Series 7, that cover the different local applications. Then we've got data centers. There are a few OEMs that have obtained FM's data center approval. So when a given data center is set on using water for its protection scheme, water mist is obviously something they ought to think about if they're concerned at all about collateral damage, because again, with an automatic nozzle, we're going to have half the water output that we would expect to see with a sprinkler system. And we can do either wet pipe or we can do pre-action, where we have a dry pipe where we're holding the water back from the pipe network with a valve. We also have industrial oil cookers, and this one sometimes surprises people. People grow up thinking water and oil don't mix, never throw water on a grease fire because you'll spread it all over your kitchen. And that's very true for homeowners. That is not true at all with industrial oil cookers. Water is a fantastic agent for this application, as is CO2. We do see people retrofitting oil cookers from CO2 to water mist for life safety reasons. CO2, you have to take a lot of extra precautions to make sure you give people a chance to exit the space before the system even goes off. So a lot of people are opting to use water mist, and water mist works so well on oil cookers because you have to do two things. You have to knock the flames down as quickly as possible, and then you've got to cool the oil to below its auto ignition temperature as quickly as you can so that you don't get reignition. And when we test our systems to the FM protocol, FM's going to make sure that our nozzles and our nozzle arrangement are not going to splash oil all over the place. So water mist is ideal for industrial oil cookers as well. Next slide. Then we've got the final three FM predefined testing protocols and approvals, and these are kind of the niche applications. You have a few water mist manufacturers that have gotten approvals for one or more of these niche applications. And I won't go into great detail here because I see we're at the 48-minute mark. But wet benches are a Class B type hazard where we've got little vats of either acids or solvents that we're using to clean or etch electronic parts. And we protect these with a deluge system where we're going to flow water out of all heads simultaneously. We're going to protect below the below cabinet space, the working surface, and the above cabinet space. So we've got exhaust hoods here sucking the toxic fumes out of the workspace, and we've got to take that into account in our protection scheme. And FM data sheet 7-7 tells you everything you would want to know about protecting wet benches. We've also got wood board presses where we're taking wood dust or wood chips and manufacturing oriented strand board or particle board. And when we do that, we're working with synthetic resins and wood dust, or wood dust and paraffin or paraffin-like materials, which all of which are obviously very flammable. We're also working with massive presses that push metal plates down to compress these particles together to make a board. And where we've got those presses, we've got hydraulics. So we've got hydraulic pits underneath these wood board presses, and they are very much subject to ruptured hydraulic hoses. So spray fires, pool fires, we test our systems to all of those when we want to get a wood board press approval. And again, there's some great diagrams in data sheet 7-10 that tell you how to protect wood board presses. And then finally, fume hoods. This is a negative pressure environment that's enclosed on all sides, but it's got a movable polycarbonate or glass window that allows a technician to get their hands in there and work with materials that have off-gassing or other noxious substances being given off that we want to suck out through an exhaust system. And in the case of fume hoods, we use automatic nozzles per FM's protection scheme. So again, there's a data sheet. This particular data sheet is the FM data sheet that addresses facilities processing radioactive materials. And I think just because that's an environment where you'll find a lot of fume hoods, but you'll find fume hoods in laboratory environments, university environments, anywhere where people have to use their hands to mix stuff together or process stuff. And again, with fume hoods, we're talking about pool fires, spill fires, splash fires, and bottle breakage fires. And if you're using a water mist system that has this approval, it's specifically been tested to handle each of those types of fires. Next slide. Jonathan talked a little bit about performance-based design. So there are thousands of applications that don't fall within those 9 predefined FM approval categories. So there's a couple of things you can do when you run into a situation like that. One, you can partner with an OEM and go to FM and say, hey, would you be willing to establish a testing protocol for this application? And FM's proven to be receptive to that. Or you can just work with the OEM and come up with a performance-based design. Next slide. And as Jonathan said, when we do performance-based design, we're going to mock up an enclosure to mimic your specific hazard, and we are going to test our system and find those design parameters that are most effective for that particular arrangement of things that you will find in your hazard, and we're going to generate a test report. And that test report is something that the OEM and the buyer of the system are going to stand behind and use to satisfy the local authorities that need to approve that system. And just want to stress again, unlike a sprinkler system, that we use a totally different design principle. We are not designing to achieve a particular water density for a particular type of combustible as we would with a sprinkler system. So with the sprinkler system, if you're protecting this type of combustible, you can look in the NFPA, I think it's NFPA 13, and it will tell you you have to achieve this water density, and you design your system to do that. That is not how water mist systems work. With a water mist system, it's proven by doing it, and the design principles are determined by having successfully extinguished fires in those types of environments. Next slide. So just summing up, hopefully everything you've kind of heard today, water mist really, I think if you talk to any manufacturer or installer company of water mist systems, I think unanimously we would say that water mist has experienced a renaissance in the past 5 years or so. We've seen more systems come on board with different features, and we've also seen just the education curve finally start to take hold among AHJs and specifying engineers. And they're starting to understand that water mist systems are faster acting than sprinkler systems because we're using automatic detection in those machinery spaces and turbine enclosures. They're less damaging. We're going to put out 50% less water in a light hazard environment and up to 90% less in a machinery space. They're cost effective especially on very large spaces where it might not be practical to use a gaseous agent because we're paying for every pound of gas that we use. So there are sort of tipping points where you would say water mist is my best option because of this volume. They're versatile. You can use a single pump style and use it with the right water mist nozzle and protect hundreds of different environments by using different nozzles and different design parameters. And then water itself just applies to so many different hazard types. And obviously water mist is green. Water mist is also ideal where we've got very hot Class B spray fires. Water has been used to protect light hazards since the mid 1800s when sprinkler systems first came out. And water mist obviously is kind of a step beyond a sprinkler in terms of its effectiveness. And then we've got remote locations where you need a self-contained unit that might have its own nitrogen source to power the unit and its own water supply. So hopefully that gives you an idea of why we've experienced this rapid growth in recent years. And next slide. And you just click through. Yeah, so NFPA 750, if you want to learn more, I would encourage you to read NFPA 750 cover to cover. It'll tell you everything you want to know about water mist. It'll send you down a rabbit hole of references to other NFPA standards. FM 5560 talks about the test protocols that we follow and some design principles. And then you can find an FM data sheet for every hazard that will give you very specific guidance. Manufacturers' test data, manufacturers' manuals are other great sources of info. And then FSSA is in the final editing stage of publishing its water mist guide. And this will be the latest addition to FSSA's library of technical publications that are really useful to the very inexperienced and the very experienced. They take you from A to Z. They're written by the engineers that work for the companies that manufacture these systems, and so are a great source of information. And finally, I would encourage you to give me or Jonathan a call or send us an email. We're always happy to talk about water mist.
Great. Thank you, Jason, and Jonathan as well for a very informative presentation. I also want to, again, thank our sponsor, Victaulic, for this webinar. We do have some questions. I know we're short on time, but I do want to go through 2 or 3 quick questions. But before I do that, I did want to mention, Jason just discussed the FSSA Water Mist Guide. That Water Mist Guide is going to be available in February of next year. Our technical committee works very hard on these guides, and if you want any additional information about this Water Mist Guide or any of our guides that we offer, please visit our website at fssa.net. So just a couple quick questions before we close. Jonathan, I'll start with you. A question came in. Is there an actual UL listing and or FM approval for local application in hydraulic spray fire hazards?
So the answer to that is FM does have a local application approval for spray fires and pool fires for hydraulic fluids. UL does not have anything at this particular time. However, I would only assume at some point in time UL will probably come out and do some sort of new test protocol development for water mist systems, in the future.
Great, thank you. Jason, I'll throw this one over to you. Is there an accepted or common or best practice to address concerns with cold water damaging hut protected equipment or housings when activated? Go ahead.
Good question. If you read any manufacturer's manual, and this is usually present most present when we're talking about protecting combustion turbines, there are very specific guidelines on nozzle placement so as to minimize the amount of water that is going to come into contact with hot metal surfaces. We want to minimize that as much as we can so we reduce the likelihood of thermal shock. And you find those guidelines in the manufacturer's manuals, and those guidelines come from the FM tests that they perform.
Hey, Todd, if I could just add something to that too.
Sure.
There is some public data out in the marketplace about thermal shock when it comes to gas turbines. So, I'd probably search that out. I know GE had done some testing a number of years ago on their turbines and released a public report regarding that and showed that water mist did not have a warping or a cracking issue with on these type of hot surfaces.
Okay, great. Thank you. Another quick question here. I'll let either one of you jump in. Regarding the restaurant example, and I think this was a slide that Jason had, does the IBC, the International Building Code, allow for a water mist to replace the building's wet automatic sprinkler system as the primary system in a building?
I don't know off the top of my head if IBC allows that or not. Local authorities will, in many cases, let it act as the primary protection source. I don't know if, Jonathan, if you're more familiar with the IBC code.
Yeah, so from an IBC perspective, I would say that there aren't any changes that allow that, although the authority having jurisdiction could say that he will allow it. The places that you would in a restaurant type of setting be able to apply these would be more in the light hazard type of areas, so everything surrounding the kitchen and in the kitchen, with the exception of protecting the appliances within the kitchen itself.
Great, thank you. And I know we're running over time. I'm going to throw one more question. We have a lot of questions coming in. I'll throw one more question out to you guys. How do you determine the use of a high pressure or low pressure system? Is there any specific guidance to tell us what's the better, or is it just based on the application or the product available?
So
I'll jump in.
Go
ahead.
All right. So, the determination, I think, of using high pressure or low pressure, just comes down to, a couple points. One is, from high pressure or low pressure may use different quantities of water for the same application. So you need to look at that. There may be some cost considerations, those type of things. Jason, go ahead.
Yeah, I would say both high and low pressure systems have various different approvals. In many cases, they overlap, and Jonathan said it. Sometimes you have to consider everything, including cost and performance and collateral damage, and make the decision that's best for you. In the end, fall back on the approvals. If the system is approved for that application, you should feel confident using it in that application, and then just weigh everything else against what's important to you.
That's perfect. Again, thank you both very much. To all of our listeners, I know there's a lot of questions still coming in. We're up against the clock, and I'm going to have to close this out, but I want to encourage anybody that had a question that it wasn't answered. Feel free to go to the FSSA.net website, shoot us an email, send those questions over to us. We will get them to the presenters and get a response to you. And I really appreciate everybody's enthusiasm and involvement in today's presentation. So again, thank you to both Jonathan and Jason for a great presentation. Thank you to our sponsor, Victaulic. And with that said, I'll throw it back to Becca.
All right. Thank you, everyone. And thank you again for joining us this afternoon on FSSA's webinar. I will echo Todd's big thank you to our webinar sponsor, Victaulic. And as a reminder, the presentation will be available on the FSSA website within the next week. Thank you, and we look forward to having you with us soon.